Hello, class. What's going on? This is just me, Mr. Wee. I just wanted to give you a screencast of maybe two or three different points from where we left off on the lecture on Wednesday this week. So that way I don't have to go over it again the next week. I want to fit in as much good content and workable content that we can work into the study groups. So I think I was a little bit slow in trying to convey some of the information. So I want to make the screencast for you guys to kind of, maybe help you out a little bit. So the stuff I go over is by no means an end all be all the content that you need to know for this week, this week's assignments, I mean, on the pacing guide. But I think there's things that I think are a little bit harder on your own to kind of think about and things that are still important within the course that I think is very relative to kind of bring up. On the right here, you have this amazing website called Desmos.com. So if you go to the right here, this window on the right, this is an online calculator. You just go to Desmos.com, and then you can type in awesome functions like x shift 6, that's the caret sign, 2, that's a parabola, x squared. Okay, you can also go down here and write some functions. I'll model it as I go along, but you can do like cubic roots, like x minus 1, see, and then you can zoom in and out, like kind of rotating the wheel on your, or like on your mouse if it has a wheel. Okay, you can zoom in and out, you can do a whole bunch of different things, and most importantly, you can trace it too, just like your TI-83 if you learn how to trace. Now, the only downside of this is, the only downside really to this, using this program, is you're going to get used to it, and if you use this throughout the year, you don't use like a TI-83 that I have right here on the left hand screen right here, okay? Or any other like AP exam approved graphing calculator that you can use on part one, or I believe, of the AP exam. Then you'll probably be fumbling around with this if you don't have that much experience using this guide to do everything that you need to do. So we'll go over briefly through the year what things you can do with this and what things you should look at when you're using this. It's not as calculator heavy as, say, AP statistics. If you're planning to take that AP statistics, you definitely need the calculator more. This is, you can get away with using this a little bit or a bit less. Okay, anyways, let's go ahead and continue off with the content. Okay, so we left off at 1.2. Sorry, not a great colored pencil. And let's go ahead and expand the screen for now until I actually need Desmos. 1.2 functions and graphs. So again, I might just go through 1 point, stop this video, make a part 2 and a part 3. And I don't know if I'm going to be able to do this throughout the whole year, but I'm going to try my best. I think these are really helpful, these screencasts. Okay, so first of all, let's talk about a function. What is a function? You typically see it written as something like the f of x, okay, is equal to some kind of equation such as this. 3 or cubic root of x minus 1. What do you know? That's sort of like something that I brought up earlier, okay? So if you look at this, okay, this right here is what we call the object or the input value. Something that you input, a value that you input into this whole thing called f of, which is the function of x, okay? I put in this x into here. Here's my object. My object's going to get placed in here and get manipulated around by this whole thing called the function. And it's going to give me some kind of value if I put in a value for x. That just tells me I can put in multiple values for x, the input, the object, or whatever I put in to this whole function in the here. And then see what I get as a value. Let's say I get some kind of number. That number is also equal to y. This is what we call the output. Okay, so it's O-U-T, P-U-T. Okay, it's kind of hard to see here, but and by the way, before we move on, let's talk about the domain of this guy. It's actually all real numbers. The domain of this function is all real numbers. That means I could put any real number. That just means you can't think of numbers with I, just like I is an imaginary number. Remember that, like the square root of -1 is I. Okay, I'm not going to get too far into that. Any real number, 0, 1, 2, 3, 4, and so forth, I could put into this problem. Normally, you couldn't do that. Normally, you would see that maybe, don't write this down, okay? Just, this is a little bit of a tangent, but something that's very important. If it was just a pure square root, remember, this is a cubic root. if this is the square root of, let's say, anything that's less than 1, see, like if it was like if x was less than 1, it'd be 1 minus 1 is equal to 0. But if it was less, if it was like -1, so let's even try that. What if it was 1 or -1 as my x value minus 1? If that happened in a pure square root, you can't take the square root of a negative number, a square root. Okay, but this is not a square root. This is a cubic root. This right here, the square root. So if you look back at the function of a square of x or square root of x, the domain would then be, the square root of x minus 1. The domain, this is a d. The domain would then actually be, what is it? X must be greater or equal to 1, meaning my x values have to be greater than 1 because you cannot take the square root of any negative numbers. Okay, so you have to ensure that your x could be greater than 1 or even equal to. If it was just 1, it would be 1 minus 1, and you take the square root of 0 at 0. But with the cubic root, you don't need to worry about that. Okay, so again, the green part you didn't have to write. I just wanted to kind of bring that up. Sorry, Mr. Wheel likes to make a lot of side notes. And that's probably why class goes on pretty slow, slower than he wants. Okay, so anyway, back to here. The cubic roots are okay. You can put in negative numbers. So like, let's say that we take the cubic root of, again, green, don't write, okay? Cubic root of -1. If you did that, it would actually just be -1. Okay, meaning if you take -1 and multiply it 3 times, okay, that'd be -1 cubed, okay? It'd be -1 times -1 is 1, positive 1, times -1. That just gave me -1 again, right? But if I took the cubic root of that, right? If I took the cubic root of that, this would kind of sort of cancel out and still just give me -1. It just goes back to the original number that you took the cube of, okay? So again, negative numbers work perfectly fine for this. So that's why I say the domain is all real numbers, right? Sorry, erasing is a bit of a mess, but for me, it's good to kind of show you guys what you guys do need to read or write and what you don't need to write. I'll tell you swiftly, or I'll just erase it to let you know. Don't take note of that. It's just don't actually write down notes, okay? Unless it helps you. It's okay. Anyway, let's get back to this. We know the domain is real, all real numbers, and we know this kind of idea of function, input, output. Let's review that one more time and visually. I think most of you guys might have recalled this. Here's like a list of all the input values I could put in. Then it shoots over and gives me values to the y, which, by the way, each of these input values should ideally only give you one output value. Mathematically speaking, that is how you technically define, this is my finger, okay? That's how you technically define a function, a mathematical function. An equation is a function, air quotes, okay? If each of your input values has only one output value. If you have an input value that gives you two output values, these are your output values, you're not a function anymore. You're not a function. You're an equation, but you're not a technical function. We're talking about functions here, okay? So how did I get from input to output? I had to put all my x values through what's called a function. Get it? An f. In this case, arbitrarily called f. This could be something else. It doesn't have to be f of x. It could be g of x, and it's still a function. What matters is the notation you write. The letter with parentheses with an input value, that indicates that you're talking about a function mathematically. Okay? Okay. So we got that. You know what? Let's just, I'm going to write this in black. I don't know if it'll show up differently. I'm going to write another function. Oh, actually, I think I have to stop the video. I'm using a temporary program that isn't free, so I'm going to have to pay for the real thing. Okay, we'll continue on in part 2. Thank you so much for being patient. Don't worry, there's a part 2. I'm going to continue on.